Good morning, good afternoon, and good evening, LinkedIn and Twitch. My name is Mike Lossmann, and I am a technical product marketing manager at Forward Networks. Welcome to our first Demo Tuesday. These are designed to give everyone a view into what Forward Enterprise can do and how it can help network and security operations teams get insights and get mean time to resolution and mean time to insights into their environments. Rather than kind of position this around this is what it can do with some static things, I thought it would be pretty cool to put you in the day in the life of a network architect. This network architect works for an organization called Rathco Inc., and we're going to see how Forward Enterprise can help him throughout his day. So let's take a quick look and see if Mike got any emails today. Bear with me 1 second. My email does not want to behave today. All right, here we go. So we can see that there are a few tickets that came into the queue. So if you heard about any issues with the web VIP, outside users can't access web.rathcoinc.com, and is the web VIP down? Okay, so normally when we're looking at an issue like this, it could be one of a multitude of things: routing, firewall, NAT, load balancer. Typically, it would take an engineer just a couple of minutes to understand what the infrastructure looks like and where to actually go and attack. So let's see how Forward Enterprise can make this particular issue easier for the engineer to solve. So we switch over to Forward Enterprise, and we're going to use our search bar to get the information that we need. So our search bar, we can think of that as Google for your network. So we're going to give it in plain English exactly what we're looking for. So since this is coming from the internet, we're going to do a quick from, and we're going to say anything coming from the internet. Then we're going to say our destination. So our destination IP is going to be web_app_pubvip. And our port, we know they're using 443, so they're using SSL. So we're going to search for a layer 4 desk port of 443. And in a matter of seconds, we can see on the paths side of the screen that the packet is coming through the internet. It hits the Atlanta internet router, hits our ISP edge device, and then is being dropped by the firewall. Now, typically, this is where we would start to triage and we would look at, okay, what's wrong on the firewall? Is it the firewall? If we see what the problem is, we'd put in a change request, and then we would fire off the change request and then make the change. But what if this firewall isn't the only problem? What if further on down the line, there's a problem with this flow? We have a notion called permit all. So essentially what this does is this negates every firewall in the path of the traffic flow, or any access list in the path of the traffic flow, or anything that could be blocking it in the path of the traffic flow. So you can see, first and foremost, is there any end-to-end communication? So when we hit permit all, we can see that, okay, so we have one firewall blocking here. So we have ATL Edge Firewall is blocking it. Then we hit our ISP Edge device. Then we hit a CE. We hit another firewall where it looks like we're not having any issues. And we're going through the packet flow, and it looks like the packet gets delivered. So, okay, we know now that the issue is with this firewall. So what can we do to ensure that if we have to make a change to this firewall, that it's not going to break anything else that we potentially have? So Forward will actually let you come into the firewall, and we can see exactly what this firewall is doing. So we see it's hitting a access list called out inside, and we're going through some NATs, and we should be going through how we're actually going to route out via our layer 3 protocols. You can see inside this tile that it was actually denied, but we're ignoring it because of our permit all mode. So if we go to see device state, we can actually see what is attributing to this particular rule and why this was actually blocked. So now we know that, okay, we need to modify this firewall, but how can we modify this firewall? So now looking at what we're hitting, so we're seeing that, okay, this is the rule that's pretty much, so like this is the rule that's denying it. And now where could we potentially insert this group? So we see we have a rule above here that says web app to OpenTCP. It looks like OpenTCP for some reason just has SSH. So what we can do is we can edit this sandbox, and we can actually put in the relevant Cisco config, since this is an ASA, as to what it should be, what we think it should be. We can save it to our sandbox, and then we can reprocess this config. We can do this with anything access list related or anything NAT related. So right now what it's doing is it's reprocessing the snapshot. It's looking to see, it's rerunning our math model on this snapshot, and then it's going to give us back kind of what you would see in a forked Git, another snapshot that we can see, okay, this is what we did, this is what changed. And the cool thing is, if we have a concept called verify, where you can write your own intent checks to make sure that the network is performing as you want it to perform, change by change. So if there's a change that's made that inadvertently affects any intent that you have, you will actually see that a before failed and then after failed. So let's see if we had anything before that passed, that failed. So this change shouldn't alter the intent of the network. And if we come back and if we rerun that search again without permit all, we'll see that now all the traffic from the internet to this particular VIP is now being delivered. So we can go ahead and we can call that ticket complete. Dealing with an issue like that could have taken the engineer a few hours to figure out exactly what the topology looked like, if anything changed. Snapshot by snapshot, as we take snapshots of the network, we're recomputing what that network looks like in real time. So this way, you know, you always have an up-to-date network diagram whenever you take a snapshot, and all the state and config that we take and that we process through our math model, you know that you're getting 100% behavioral accurate representation of the network and how the network should respond to this specific flow that we were searching for. If there are any questions throughout any time in this presentation, please use the chat. We have people monitoring the chat who will either answer the question there directly, or they'll pass it off to me and I'll answer the question live. So let's go back and see what the mailbox looks like for this particular network engineer in Rathco Inc. Whoa. So it looks like there's a massive outage that has really nothing to do with what we changed. It looks like there's some issues connecting to AWS from a specific host. It looks like it's a specific host in our NSX environment. So we're going from NSX to AWS. Man, these types of, now they want me to join a Zoom. So these types of troubleshooting calls, when I was in the trenches doing network engineer work, always hated these troubleshooting calls because you'd be on the call for hours on end with several teams. You'd have the firewall guy saying it's not me. Me being a network guy, I can only check to make sure the roads are good. Then you could have a transport guy saying my transport is good. Then you have the cloud guy where the cloud guy says, hey, the cloud's good. I don't know what the issue could be. And then you spend a couple of hours just arguing about whose issue is what and kind of how to best fix the issue expeditiously, since everyone says it's not their problem. Forward could actually help you with this and actually give you the mean time to insights pretty quick. So let's see what's going on, and let's see how Forward paints this picture for us. So we're going from our NSX host in the data center. We're going to a destination IP in AWS of 10.5.22.96. And since we know they can't SSH, what we're going to do is we're going to search for an app ID of SSH. Let it reprocess, and in our paths pane, so what you're seeing is you're seeing one of 17 paths. Because this is a VXLAN encapsulated flow, what you're actually going to see is if we click this dotted link, you're going to see that it is VXLAN, and we can view the underlay, and those 17 paths are the 17 paths that you can see on the underlay. So this is just path 1. If we were to go back and click through to the other paths, you would see that that VXLAN underlay changed just a bit to modify. So not only do we show you the VXLAN overlay, we also could extrapolate the VXLAN underlay in case there is an issue with the underlay. Going through, so we see, let's collapse these tiles for a second. So we see the packet starts in Atlanta, goes to San Jose, goes back to Atlanta again. That's not right, but that doesn't seem like the issue here. Then we jump into AWS, US East, then we can go to AWS, US West. So let's explore how this packet is actually traversing the network. So we start off in Atlanta at a distributed vSwitch. Then we go through NSX. We get spit out an access list in an access switch in the San Jose data center. And all these devices are clickable. So you can go to a device and you can click it, and you can see why the packet was forwarded the way that it was forwarded. Whether it's layer 2, layer 3, layer 4, you'll see all the decisions that are made that we get from state that we compute, and how the packet is modeled throughout the network. So we see another firewall. It looks like this firewall is permitting the traffic. We could also model MPLS. So as we get into the MPLS network, you can see how labels are pushed and popped as the packet traverses. And then as we click through, you'll see in the map screen that the map will actually change, and it'll show you the relevant part of the network, and it'll also highlight the device that we're currently looking at in this particular card. So we keep going through. We see it, no issues in Atlanta. Then we see it jump out into AWS. So AWS to most network engineers is just a black hole. It goes from either a direct connect link or from a VPN tunnel into some kind of transit gateway, and then it just vanishes. Nobody knows where it goes. Nobody knows how the packet gets from point A to point B. But with Forward, you can see all the AWS constructs that this particular packet is hitting. So you see it's hitting a transit gateway in US East, then it bounces to another transit gateway in US West, shows you all the attachment points, all the routing, and you can actually pull up the configuration and see exactly what that route table looks like for that particular transit gateway. And you can actually click through all the relevant information to see exactly what you want to see about how this packet is being processed, or how any subsequent packet could potentially be processed. So now we're going into firewall VPC, and you can see we actually lay out the availability zones, the access lists, the route tables, the subnets. So we're bouncing through a few things. So we hit an AWS subnet, then we hit another routing table. We keep going through. We hit a gateway load balancer to a pair of Palo Altos that are apparently in AWS. Those don't look to be blocking anything. We hit a gateway load balancer. We hit another VPC attachment point, and we keep going till we hit so we hit the same transit gateway. So we came in, went to the firewall, went back to this transit gateway, and now we're going to hit the front door to the prod VPC. Then we finally get to the database subnet, and we see that this packet is being dropped at the database subnet, and it is being dropped because of a cloud network. It's being dropped because of a cloud ACL. I've been in troubleshooting scenarios like this where it has taken legitimately hours, if not days, to get to the root cause of the problem, because generally security groups in AWS, once you set them, they really don't change, and that's the last thing the cloud guy is looking at. So it would legitimately be a cavalcade of the network guys testing every which way, the firewall guys trying to figure out what's going on, throwing fake packets through firewalls, potentially trying to rely on old tools to test whether it's ping or traceroute, which, depending on the organization, those particular protocols could be blocked because they could be seen as a security risk. So now you're relying on tribal knowledge of how stuff was set up. Diagrams generally aren't updated in a timely manner, if at all. Just the amount of work that would go into troubleshoot a hybrid deployment like this, to be able to turn around and say, oh, I know exactly where the issue is, and I know exactly how to fix that issue in seconds rather than hours or potentially days, could very well have saved this organization a ton of money. All right. And while I was going through that, I actually got tapped on the shoulder by a database guy who was next to me, who is decommissioning a switch. Sorry, who is decommissioning a host. And he wants to know, what port does that host live on? Now, you ask any network guy who's in a large data center, finding a host is like finding a needle in a haystack. You got to start off at the core, work your way to the distribution, and then from the distribution, you have to work your way to the actual access switches or the leaf switches. If you have more than one distribution, or if you have more than one core, this is bouncing around from core to distribution to access to try to figure out where this host is. And it's never good for decommissioning, because when they unplug it, you really don't know what that device had access to, where that device had anything configured, were there NATs, were there firewall rules, what if that IP gets reused for something else, and now all of a sudden you have firewall rules that are open to a host that shouldn't have firewall rules open. With Forward Enterprise, what you can do is you can search for an IP address. So think of this again, like I was saying, Google for your network. With all the data that we collect, we take it, we extrapolate it, and then we make it searchable. So we normalize the network. We normalize all the network data that we get. We make it seen, as you saw, in a vendor agnostic way. So we're not telling you if it's a Cisco firewall or a Palo firewall or a Cisco switch or an Arista switch. We're giving you the information that you need in order to make the decision on okay, does this look right? Is Forward saying there's a problem? Does this look right to what I know the network should behave? Does this look right to how the packet should be flowing? So it's giving you information that you can use to make that determination, or have Forward make that determination based upon if it sees a loop or if it sees it being blocked by a security device. So let's search for this IP address, and 133. So we can see that this host lives off of an access switch in Atlanta, in the Atlanta, DC, on ACC04. So not only do we know the VLAN, what it's connected to, the IP address, what it is, because we do a OUI lookup based upon the MAC address, but we're also letting you know based upon data that we can get, because we integrate with Tenable and Rapid7. We're giving you host vulnerabilities that Rapid7 and Tenable feed into us. And then we're also going to show you the vulnerabilities of the switch if there are any. And then we also show you every place where this is configured. So you see all the ACL rules that have this particular host a part of it, whether it's the host itself or the subnet the host lives in, any NAT entries that this host has configured for it, the interfaces, the ARPs, it's all, it's all just text. So we're just looking at text, we're matching text, and we're saying, hey, if you, this is where we see this configured. So if you are decommissioning, then you have a really good data point to go in and say, all right, these are the firewalls I need to remove this from if it is a host entry. This is what I need to do with NAT if it is a host entry, and kind of have a more proactive way to decommission equipment rather than just decommission and then find out 2 or 3 months down the line when that IP address gets reused that it's now susceptible to a new vulnerability on a port that should never be opened on a firewall. All right, so that is how Forward Enterprise can help the network engineer in their day-to-day tasks. Essentially, everything that I had just showed is something that could take hours, if not days, to troubleshoot, get the right answers. Whereas with Forward Enterprise, we got the data that we needed and we're able to solve and fix those issues quickly, rapidly. Our mean time to insights went up. Our mean time to resolution went up. All good things across the board. Let's see if there's any questions. Any questions out there in LinkedIn or Twitch land? All right, with that,